All right, so I'm going to demonstrate here how to do a one-way ANOVA in Excel. It's pretty straightforward. You want to make sure your data analysis tool pack is installed or is added. And just go to data analysis. So here is the data, and we have 4 different groups. These are independent groups, so this is not paired data. One giveaway is that we have different sample sizes in each one, which still works fine with the one-way ANOVA. Sometimes you will have equal sample sizes, and you'll need to know if your data is paired or unpaired. We won't get into how to handle paired data in this video, but that would be a separate case. But here, these are 4 separate groups that are independent of each other. Select ANOVA single factor here, and then the input range, you select just all of those columns, all of it, even if there's some missing here. And then here you indicate that the data is grouped by columns. If you had this oriented a different way, then you could say group by rows, but here we say group by columns, and that's how data is typically organized. Check this box that we have labels in the first row, and then we'll do this, select an output range and select this cell here. Hit OK, and here is our output. Now you can see there's a lot here. The relevant things that we're looking for are, it's always a good idea to look at the averages and just get an idea of how different they are from each other. The null hypothesis for a one-way ANOVA is that all the means are equal, and you can see that there's a decent bit of difference between these means. Hence, this F statistic of 29 and a very low p-value makes sense, that we would see strong evidence against the null hypothesis that all of them are equal. Here are your degrees of freedom for between groups and within groups. And these are your mean square between groups and your mean square within. This F statistic is just a calculation of the ratio, this divided by this. And this is where the term analysis of variance comes from. You're looking at the variance between groups versus the variance within groups. If you have a high degree of variance between groups compared to within groups, basically to really reject the null hypothesis, you need groups that are very different from each other, that are really tight, that have very narrow distributions within them. So that appears to be the case here, and so we have a large F statistic and a low p-value, so we would reject the null hypothesis. Okay, when you're reporting a result, you're going to especially need the F, the degrees of freedom here, and the p-value. Okay, so that's how you do one-way ANOVA in Excel.